Can you see my screen?
Yes.
So good morning. Today I'm gonna talking about exploratory structural equation modeling, ESEM. I'm not expert in this kind of modeling, but I'm gonna to try my best. I started to study recently. It's really interesting approach to do, but they have some tricks. And if you have any questions, you can ask me before I finish the presentation in any moment. So what is ESEM modeling or just ESEM? It's a statistical technique that combine different statistical analysis. So basically, you can combine in the same modeling the factor analysis with regression. So you can do both in the same time. This approach allows the examination of a complex factor structure while also allow the modeling to be testing and evaluated. So if you are thinking to do exploratory factor analysis, you can do the exploratory factor analysis and then you can measure your model to see if the model fits in a adequate way. So the ESEM, the ESEM almost of the times provides better goodness of the model fits, less inflated factor correlations, and meaningful cross-loading. I don't know if they can be doing in another different program, but I did all my analysis in our program using the latent package. The latent package is really easier to understand. They have a really nice tutorial that you can just follow up to. They explain step by step all the process steps. So it's really easier. Uh, okay. So, like I said, you use the ESEM model combine different statistical analysis. So you can use to do analysis of latent variables. The latent variables are variables that cannot be directly observed or measured, like happiness. You can use to do pathway analysis, to do EFA or CFA with regression, like I said before. And when you do EFA or CFA with regression, the regression, you have to be a little careful because you cannot change the variable distribution. So your data has to have a normalization. But we can talk this after. And you can do to make a causal relationship between multiple variables. So you can use to do mediation or moderation analysis. And you can also do to do a longitudinal association. So basically, you can apply ESEM model in a really different approaches when you have a lot of dependency variables and you can try one outcome. So you can do all these integrations of different techniques. They have some advantages, like it's more robust, rigorous, and flexible than most analytical approaches. So when you can do in the same model both CFA and EFA, and the model fits it significantly better than a traditional CFA or EFA model. You can estimate less restrictive measuring models that permit useful fit index and parameter estimates. For the latent factor correlations, they are less biased and are closer to the true association. And this model are usually more in line with the theoretical conceptuations and considerations of the construct, the instrument intended to measure. So the literature has shown a lot of advantages when you apply this model in your data, but you need to be really careful because sometimes you have the best fit of your model, but not necessarily this is the best model of your data. So when you're trying to find the best model fit, sometimes you need to do a lot of adaptations in your theoretical model, and this adaptation does not explain anymore your data. So you need to be really careful about this. But talking about the steps, they basically have 5 steps: model specification, data preparation, model evaluation, alternative models, and interpretation and reporting. The last 2 steps, it's more the way that you're reporting your data. The 3 first steps, there is the more important that you need to really pay attention in what are you doing. So in the model, starting with the model specification, in here, you need to make a theoretical hypothesis of your data. So like if you're seeing here, I have a theoretical model that I am to analyze in my data. So I'm trying to understand the work performance, and I have some dependence variables like happiness, like work role, and the gender. So when you do this diagram, it's diagram? It's diagram?
Yes.
Okay.
Yeah, I think so.
When you do this diagram, the diagram has to be acyclical, has to be with just one direction. So they not be bidirectional. So this is the most important step when you are doing this kind of modeling. Then you need to prepare your data. So when you prepare your data, so if you're thinking to do a regression, that it's the most of the time this model it's used to do a regression. I said before that you cannot change the distribution of your data. So you cannot do a Poisson distribution or a gamma distribution. So your data has to be a normality distribution. Also, you can check the absence of multicollinearity, and you has to be a really appropriate sample size. Because if you have a lot of dependence variables in a sample, in a small sample, you can try different approaches that no one will fit because of the sample size. So this is basically the most important when you are preparing your data. And also you need to be careful with the missing data because sometimes if you have a lot of missing, the data doesn't fit and you can find like a lot of errors that are not explained. After the data preparations, we started to do a modeling and evaluation, try alternative models, and then interpretation and reporting. The alternative models you need to do because you want to show that the model that you propose is the best for your data. So you change the relations in your model to show that, okay, my first model is the best one for my data. It's the best one that explains my output. So you're going to talk more deep about each of these steps. Starting with model specification. In the model specification, you have to do a theoretical hypothesis. To have this theoretical hypothesis, you can like have some previous hypothesis that you are studying, or you can find in the literature. So basically you need to propose a hypothesis. You cannot start an ESEM model without a theory. So you have to do this. But if you are trying to combine EFA with regression, the EFA allow you to explore your data before to do a regressions. Just for curiosity, when you read some ESEM papers, they change the name of some variables. So the independent variable that you we read in some papers, in the ESEM model, they call it exogenous variable. And the outcome that is the dependent variable, they call it endogenous variable. And they have like a patronized way to do the diagram. So when you use a cycle, it's a latent variable. When you use a square, it's an observed variable. And then we have arrows with covariance and regressions. So when I do this diagram, that it's like wrong because I didn't put my outcome in a square. Sorry about this. They have some specific way that you can like do this diagram. So starting with the model specification, I have an example. So my question is, do happiness and or work role influence your work performance? So I need to test this hypothesis that I propose these questions, and I have some dependency variables that I did a diagram. So the work role influence directly the work performance, or the work role influence the happiness, and the happiness then influence the work performance. And I have the gender that can make an influence in the work performance. So this is my theoretical model that I did based on the literature. So I have in here a latent variable that is happiness. So happiness, I cannot directly measure happiness, but I have some measurements that I can influence happiness. So I have a latent variable, I have a dependence variable, I have my outcome. When you're doing this in our program, they change some operators that it's important to you know. So when you are defining the latent variable, it's this kind of operator. When you're doing regression, it's this one, and then you're doing covariance or trying to the best adjustment of your model, you have this operator. And in here, in dark square, I have the code that we can use in our program. So I have the code for the latent variable, the regression, and the correlation in the same model. So also we will start with the latent variable. In this case, I'm not doing an exploratory factor analysis, I'm doing a confirmatory analysis, so I use a CFA. But if I wanted to do the EFA, it's the same code. I don't have to change. So just to clarify the difference between EFA and CFA, if you don't remember, both tests are used to reduce the dimensionality of the data, but EFA, it's more exploratory analysis. So the interpretation of factors, it's more exploratory and less restrictive. So you don't have to pay attention so the model fits so hard than when you do CFA. The CFA is a confirmatory analysis. So you are confirming a prior hypothesis of your data. So the interpretation, it's based in the model fit like RMSEA, CFA, and the other fits. That is the same that you're going to check in the model fit for the ESEM. So in my case, I'm doing the CFA in this example. So after I do the CFA, I start to do the regression. So in the regression, I put all the regression model that I wanted to predict. So I'm predicting that work performance is influenced by the happiness, by the work role, and the gender. But I'm trying to understand if the work role indirectly influence the work performance, influencing the happiness. So I wanted to see if the happiness is influenced by the work role. After I do all these,
Nice.
yeah, yes.
Yeah, I have a question there. You're showing on your diagram that gender like is separate.
Mm-hmm.
So maybe gender is not influencing happiness and work role, but it's influencing work performance.
Mm-hmm.
Is this your like for this example, is this the hypothesis that maybe the work performance needs to be, controlled or is different between genders? Is that the case?
Uh, no, in my case, the gender it's not is predicting just the work performance. They are not
Okay,
predicting
so
work role, neither happiness. It's just work
okay,
performance. This
I
is my
see.
theoretical model, but like I said, I need to make some adjustment. So
Mm-hmm.
sometimes the gender also can predict the work role.
Mm-hmm.
I'm gonna
So
to do this example after.
okay, sorry, but thank you for explaining.
Yeah, because like I said, you have a hypothesis. So in my hypothesis, the gender doesn't influence the work role, even we know that it's not true. So the most I should like if we're gonna to thinking in more complex model, the gender influence the work role influence the happiness, and the happiness influence the work performance. So I try to reduce it to easier explain this model. But we can change, we are going to change after. So, okay. After I do the regression code, we're gonna to test the model to do the model evaluation. And this is the part that started to be complicated, and you have to be a lot of patient because you need to change sometimes a lot of the time with a lot of frequency your model. So you need to check for parameters. We're going to start talking about CFA and TLA, and after I talking about the chi-square test. So the CFA TLA is to compare the ESEM model to a baseline model. So it's basically trying to understand if your model actually is a better model if you are compared to some baseline model. So your value has to be above 0.9 to indicate a good fitness. After, I need to check the RMSEA and the SRMR to assess the amount of unexplained variance in the model. So you need to find a value less than 0.08 and at least 9% of distribution, and your distribution should not include the zero. So basically, this is the most important that you can check, because in here you're trying to understand if your CFA or EFA model has a good fitness. When you check the ACBC, it's basically the same one that you check for the regression model. So in here, when you are comparing your model to other models, you need to check it to see if your model is the best one. So lower values indicating better fit. And the last one that you need to check is the chi-square test. So the chi-square test, they say more about your sample size than your model. So if you don't have a huge sample size, it's really hard you find a no significant p-value. So sometimes if you have the best CFA, TLA, SRMR and a good ACBC compared to the other models, it's okay if your chi-square is significantly. But just because the other parameters is okay. But if the other parameter it is not okay and your chi-square also it's not okay, you need to change all your model. Because the chi-square basically tested the sensitivity, the sample size. So basically, it's real, you just can find a p-value significant if you have a very huge sample size.
Liz, can I say something?
Yes, please.
So when we're talking about psychometrics, first of all, sorry for not opening my camera. It's not working for some reason. But when we're talking about a sample size in psychometric studies, it's always something that it's up to debate. But we also need a large sample size to be able to understand if what we're measuring is really what we are measuring. So you're going to see that there's some literature saying that you need at least 10 participants for each item of your scale. So if you have a 10 item scale, you need at least 100 people. So when we're doing this type of model evaluation or just this type of modeling, regardless of being EFA or CFA, the sample size when it's small, it can lead you to a value that it will be true, but is also going to be more debatable about the validity of the units of the fit because of the sample size. So the chi-square test the sensitivity to the sample size. So if you have like 100 people involved in enrolled in your study, and you have let's say 10 covariates, it's probably going to be significant because 100 people is not enough to be a good measure, to be a good sample. It doesn't mean that it won't have results. It doesn't mean that the results won't be reliable. It's just saying that you should try to increase your sample in future studies to make sure that the model is really measuring what it should be measuring. So the same rule that we apply for scale validation and we should apply here to the psychometrics models evaluations. So it's best to have these large samples, of course. We want that for every single research, but for psychometrics, sometimes it's a little bit upsetting how the evaluation always get these factors to be poor, but because you have a small sample size, which doesn't mean you cannot use it. It just means that sometimes this psychometrics modeling is not the best option for you. So you need to readjust your methodology or anything like that, instead of trying to adjust a model and become biased. So that's what I want to say.
Yes, thank you, Nathan. And what Nathan said is really important because it's the first step when you are doing a research that you're thinking about your sample size. You cannot do a research with 20 dependence variable in a sample size of 50 individuals. So when I'm talking in here, it's when you arrive, make all the preparations of your sample size before you start your research. So I think it's the basically when you start a new study. But thank you, Nathan, so much. So like I said before, the ESEM model, they have a lot of advantages, but like I said, excellent fit model, it's not necessarily the best model for your data, because excellent fit could also be a function of poor measurement quality. Like I said, sometimes you are change a lot your theoretical model to try to find a best model fitness. And then when you are interpretation your data, the model doesn't make sense anymore, but you have a really nice features of the model. So you need to be really careful when you are trying to adapting your model, your theoretical model, to find good measurement. So to understand the model evaluation, like I said, the RMSA and the CFA TLI, it's more representative of the CFA model. So in this model, my theoretical model, that one that I showed before, I found RMSA less than 0.08. My number is 0.05, and my CFA TLA is higher than 0.9. But if you're seeing here, my chi-square test is significantly. So I can report in this way, and it's probably okay because I found the both two measurement okay. But if I saw my ACBC, there is really higher. So maybe this is not the best model and I should try another models. So in here, I put the code that you can use to see these results. Like we're gonna to say this is the best model. So after I do that step, I need to do the measuring quality. So I need to look at the estimate and the residual variances. So my estimate should higher than 0.4 and they has to be significantly. So my latent variable, my CFA, the estimate of the CFA has to be higher than 0.54 and significantly. And the residual variance has to be close to 0, like I said here. So when I found this, I can report that it's the best model. Sometimes you doesn't have to change all your model to try to find a better adjustment. So sometimes you need just to check some correlations. So you can additionate a step in your code that is the correlations, and you can try to find a better adjustment. Sometimes when you do these correlations, the model, the fit model has a better adjustment. And this is the code that you can use because when you use this code, the program reporter the correlation that you should to do to try to find a better adjustment of the model. And like I said, like João Vitor said before, sometimes you need to change your model to try to find a better model, to report that my model is the best one that the other models. So in here, I have the gender predicting happiness. I have the gender predicting the work role, and I have gender actually like a moderator between work role and happiness. So when I do the model adaptation, I can change the regression parameters, or I can change my CFA. So in my model, I'm saying that my dependency variables, my observed variables that I'm measurement is predicting happiness. But sometimes I can change the way of the CFA part to see if the model is better or not. So yes, well, we have to change it, and maybe this one that gender predict work role, it's the best that the other model that I use it. But I'm saying that my model is the best one. So the gender is not influencing the work role, but it influences directly the work performance. After you do your model adaptation and all adjustment that you has to do, when you do the model adaptations, every time you need to check your model parameters, the feature of the model. So it's a really it's not so fast to do because you need to check in all the steps. So when you find the best model, you have to make an interpretation and reporter. Basically, it's like a regression model that you're going to report. So I'm saying that the happiness predict work performance, and I'm saying that gender predict work performance. But the work role don't predict work performance, but they indirectly predict work performance because they influence the happiness, because it's significantly. So basically, work performance influence the happiness, that happiness influence the work performance, but the work role doesn't influence the work performance. And you have to report a table with the parameters of all the model that you test. So basically, you have to report the p-value, the CFA, TLI, SMRM, and RMSEA. And if you check the first model that is related to this model, is the best model because they have the higher p-value, that it's continued to be significantly. Sorry. My CFA and TLI, it's higher than the other models, and the both two parameter, it's like lower than 0.8. So if I compare with the other models. So I'm saying, based in these parameters, that my model is the best model to my data. And then you report your results. So I think that's it. This is the reference. It's easier to find a lot of tutorials and YouTube videos explain the ESEM model, but it's basically this one. Thank you, everyone.
Thank you, ladies. It was great. Can you go back to the slide before?
Yes.
Let's see.
This one?
Yeah, that one, the number 13.
Mm-hmm.
So you started, let's say you have a hypothesis either because of your work or because of the literature,
Mm-hmm.
and you start with the hypothesis that the original hypothesis that gender was actually like here, right?
Yes.
So that's your hypothesis. But if you fit many different models and you fit the gender in different positions there, and you actually see that that the other options have a better fit or have a better, better metrics as you showed.
Mm-hmm.
So that kind of changes your hypothesis. I mean, it's not a
Yeah.
change, but basically you like you would um,
Yes. You
go
don't
to an alternate version.
Yes, you don't change your hypothesis because you had to report your diagram, your theoretical diagram, but you have to report that based in the model fit, you change the position of the gender because the gender actually predict work role. So you're basically change your prior hypothesis, but you're change just one parameter of your hypothesis, not all the model. Because the
Okay.
model is to make sense. Because if I didn't have the gender, the model makes sense yet, the basic of the model. The gender, it's just like a plus in your model. So you reported the changes that you did to find a best model fit.
Okay. Okay. And I would assume as well that like for different samples, for
Mhm.
different populations, or even like within the same population, you get a different sample, you would get different, like the best model would be different between those. Like, let's say with a group of 100 students from Duke, we see that gender is in fact important for, like, it's right here, like with the work performance. But
Mhm.
then if we go to like 1,000 students from Duke, we actually see that the model puts gender here.
Mhm.
So I guess that's okay, right? I mean,
Mhm.
that is something to be expected. The only thing we would need to do is to change the way your interpretation for these two
Mhm.
models, right?
Yes, because if you are increasing your sample, you can find the best, not the best, but better results.
Mm.
Like more, you have more confiança no resultado.
Reliability.
Real, yes, this one. So if you are increasing and the gender change, so probably with the sample higher, the
Mhm.
reliability of your results is better. So it's more,
Okay.
yeah.
And how about like Nathan, do you want to go before I keep going? Because I have a lot of questions.
No, you can ask all the questions.
Well,
Please,
like
you can also talk because I know have a huge expertise in this model.
Yeah, no, but it's everything just perfect. Just keep going, Joe. It's fine.
okay. So let's say for something that is like the same thing for happiness as well, or something like alcohol use and depression. That is something that we are working with. That is a concept that I studied, in different populations, in different settings. How do you, like, if you have a result from a similar study that was done in, I don't know, in the US, and now you are doing this analysis in Brazil, for instance. How do you compare? How would you discuss if the model that we find the best in Brazil, the best fit in Brazil, is different from the US? Basically, you would say that you would you say something like, using a similar approach, we see that apparently
Mm-hmm.
um, depression seems to be more important for alcohol use in Brazil than in the US, or in this example that you're showing, maybe compare, like, if this thing here is Brazil, we are saying that in Brazil gender influences the work role, while in the US apparently gender influences more in happiness and not in work role. Would that be the way to do it, you think?
Yeah, but I think it's better you change your cultural context because in here, maybe the way that you measure happiness is different for the Brazilian
Mm,
community to measure happiness. So,
okay.
and then I don't specify the kind of work role or work performances. So maybe depend of the when you are applying the work that you are trying to understand. Maybe in Brazil there are more prevalence of women and here of men. So
Mm,
I think you need to check your cultural context to make some adaptations in your model. Like
okay.
change the way that you analyze happiness or change the way that your gender influence in the work role because the work role in here it's more prevalence of men, in Brazil it's woman. So I think the cultural context is really important.
Okay.
So
Can I
you
add to
can use
this?
your privilege model to try the hypothesis, but you can report that uh, based on your previous hypothesis, you have to change because of I don't know, another some cultural context. Go
Okay.
on, Nata.
Okay, so I just want to add to this because this is really, really important. When you're
Mhm.
talking about like this comparison between different settings, which is something that we want to do, the cultural background is really, really important. And that's one of the things that this model basically is what we do when we're trying to validate any psychometric, any scale, any instrument, because it needs to consider the context. So for instance, if you're trying to measure happiness here in the United States and then back in Brazil or in Tanzania or anywhere else, is going to be different things. Happiness for us Brazilians is different than happiness for Americans, that is different from Tanzania. So the cultural aspect of it is really important. And then one thing that needs to be really clear when we're talking about those psychometrics evaluations is that if you look at happiness and work goals, they are latent variables. So they're not observed. We try to measure it by some scale or anything like that. And to that, we use observed measurements. So let me see if I can here. So you see this one here and this one here. They're observed. It can be self-related, but they are observed. And they will construct a latent variable, so something that we don't actually see, but we know that it exists, like happiness. We know that happiness exists. And when we're trying to get this for different contexts, we create those factors. So we have here 3 factors that will explain differently different contexts. So this one, when we're talking about happiness, is about how often people feel happiness. This one is about how often they feel sadness. And this one is about achieving goals in life. So they create those factors to be able to understand this. And when we're talking about this cultural approach, sometimes we do have some previous hypotheses. Sometimes we don't. If we do have like, okay, I already have this scale in the US, I'm going to translate it and culturally adapt in Tanzania or in Brazil. The first thing that I do is I translate it to the language that I'm trying to validate the scale to. But even if the language is the same, I'm going to do a cultural background and understand if they mean the same thing. So I'm going to gather some experienced researchers, social scientists, health scientists, health providers to understand that, okay, they're talking about the same thing. Because if you talk about like one feeling that is very specific, overwhelming, in the United States, in the English language, overwhelming is something very clear, that we don't have a direct translation to Portuguese. The feeling of being overwhelmed sometimes is known as overworked, overload, which is not the same. So we do this and then we try to see if they are the same. If they're not, we can easily adapt, like instead of 3 factors, we exclude this one and we keep with those 2. It will work as it is the same thing, but we're going to need to adapt to the local culture, to how it works. So that's why we always need to understand, like, okay, I'm adapting this to just individuals that are in an academic setting. It won't work for the general population. Every single scale needs to be adapted for any type of populations, because it needs to measure what it's pretending to measure, what is possible to measure. So if you change something here, when you're adapting culturally, it will change here as well. Because as Lei said, gender, the vision of gender is different from Brazil to Tanzania to United States. The vision of work world, the vision of happiness is really, really different. So we need to have this cultural background and understand and adapt all our latent variables, because we cannot measure the same way. That's why the results will get different, and we cannot really compare per se because we need to understand if they're different and how they're different. And then we create these concepts that will be comparable.
Okay.
Does it make sense?
The last question before Alice also has a question, but before I move on, so the factors, I want to compare then like the number 1, 2, 3, 4, 5, 6. So those are individual patient observations. And the A1, A2, A3 are the factors, which are like representations of that.
Do you want to explain it?
You can explain if you want.
Like the 1 until 6 is like your observed, it's not factor, it's your observed variable. So
Okay.
like the 1 and 2, it's like happiness, and 3 and 4, like you say, sadness, and 5 and 6, it's another context. So
So they are like questions from a scale.
Yes, in your
Okay.
scale. So you have questions, and all these questions you can like influence happiness, or
Okay.
based on each of these questions, you can make some factors like A1, A2, and A3 that you can use the separated to predict like work performance. Like you can use all these directly to predict work performance, or you can do all these A1, A2, and 3 to predict happiness, and then happiness work performance.
Great. Thank you. Sorry for hijacking the discussion there, but thank you for answering all the questions. It was
So
great.
thank you. It's correctly right, not the
Yes, it is correct.
okay.
Perfect. Go ahead, Alice.
Thank you, Nathan. Can you guys hear me?
Yes.
Yes.
Okay, sorry, I had an internet breakout. I'm not sure if what I'm asking has already been asked, but then I am trying to think loud, like for the confirmatory factor analysis, you said that you already have the hypothesis, and I believe that the hypothesis is made from the latent variables, like happiness, work role, gender, and work. These are the latent variables, right? So I'm trying to think like the collection of observed variables that made a latent variable, maybe let's say happiness. As a researcher, how do you come up with these observed variables that will help you to make these latent variables, which you'll use it to do a confirmatory factor analysis? I'm not sure if I've made myself clear.
I understand you. If you like, do you want to answer that, or can I answer it?
No, go ahead.
Okay, so for us to identify the items that will come be in a scale, we need to understand the problem first. So we go to the literature, but also we do focus groups to understand how they relate to that, how they say about it, what they say about it. So if we wanted to try to understand happiness, we will go to a focus groups with the population we want to study. And then we're gonna say, okay, what is happiness for you? Or do you feel like small things makes you happy? What's the last time you felt happiness in your life? Or do you perceive that small things makes you smile? Those are questions that you're going to be able to ask. And then depending on the responses they give you, you're going to be able to track if they're going to be a good measure of the happiness. So this constructs those 1, 2, 3, 4, 5, and 6, or any other number of variables you want to add to it. You're gonna use by understand what the problem is, what's the thing that you want to measure, and then go into the literature, what has already been said, and you're gonna create some questions about it, and then or some items or some affirmations and stuff, and then you're gonna test it on focus groups to see if they can understand it, if it makes sense. Because if I say something that makes sense here in the United States, like when I run, I feel happiness, or I run to feel happiness. It is something that, as a Brazilian, I cannot relate. Because it's not something that we're gonna do for fun, like in the daily basis. Some people will, but it's not something that everybody, the whole general population will. So it's not something that I will be able to measure happiness. However, if I say something like, do you perceive that, or it's better than affirmation, small things that happens in my daily basis makes me smile, like the rain. This is something that it's very specific. I'm just creating up to my head, but it's something that I can track happiness. Because if the person said, no, I never feel happiness when I watch the rain, or these small things doesn't make me happy, doesn't make me smile, then the happiness of that person may be not too high. So it's this how we kind of track which items should be put in the scale. Does that make sense, Alice?
Yes, it makes sense. Thank you.
Okay, we're almost cap time. Does anyone else has any question, comments, suggestions, compliments? No, okay, so I want to thank Laís for the amazing presentation. This is so good. This was really helpful. For someone that is from the psychometrics, it's very complicated, I know, so it's really nice to see people engaged on it. So thank you so much, Laís, for your time, for your amazing slides. It was really, really nice to learn a little bit more with you. I'm definitely waiting for the recording so I can watch it again. So let's meet again, everyone, next week. We're gonna have, for now,